Hello everyone, my name is Jawad Ali and today I decided to come back on this channel. I started this channel around 2017 and I just noticed that my channel is getting more views every day, more than 150. So I decided to come back on this channel and give you a little bit overview for Cisco course 200-301. So this course is really important. I'm already getting a training on this course, and I assume whatever I'm going to learn, I will make videos and I will perform an exercise, and then I will upload that video for you. And if I'm going to do a mistake throughout this course, you guys can comment down below. So let's get started. So the first thing, I'm going through very advanced topic, which is a OSPF. OSPF is very important protocol and it stands for Open Shortest Path First, and we use this protocol actually to connect wide area networks on two locations or maybe to more than two locations. So this is very standard protocol. That means you are not going to get this protocol only in Cisco routers. You will see this protocol all other companies and brands like IBM or Ecom, and this is not very designated protocol for just one company. So here are some characteristics for this protocol. This protocol supports a really huge and large networks, and this is very fast protocol. I mean, for communication, if you have a very big company, I would suggest you use this protocol, and it uses the multicast technology. That means it sends out those messages to all the routers and it checks if the router is alive or not. If we are going to compare with the RIP protocol, I will discuss that RIP protocol in my next video or any other video. So the RIP protocol is very limited and can connect only 16 routers, but this protocol OSPF can be used for very large production networks. So it supports VLSM. This is a classless routing protocol. We will discuss these both technology. What is a classless routing protocol? That means we can assign the subnets and we can perform the subnetting, and I will also discuss this VLSM thing. I have a really unique way how you guys can perform subnetting. So it has a concept of area management. That means you don't need to worry about all the routers. You can assign different router to one area and then you can manage that area, which is really good. If I have it on this slide. If you see that green circle, all the routers inside those circles can be managed by area 0. So the area 0 is very important because it connects all other areas. And so AD value for OSPF is 110, and this protocol sends messages to the other protocol every 10 seconds. It considers the other protocol dead if it did not receive a reply back or ping back within 40 seconds. So it uses the multicast technology. It sends the updates to the entire table like RIP protocol, and there's a multicast address on my screen. I will explain it later what it is. And then it's a link state advertisement. I mean, when it sends a data through a static link to another router, it uses that technology. Here's a very simple diagram which connects only two wide area network. If we see that we have a network ID 192.168.0.0, and over here we have a network ID. So I'm going to tell you how simple is it. You just need to write down 4 commands to configure it. So the commands are going to work like this. Just go to the interface, type in router OSPF protocol and then the process ID. So this number called process ID, I mean, you can provide any process ID 2, 4, 6, 8, 10, any number, and then you have to provide the NID, so which should be 0. It's wrong here. And if we go back, so we need to provide the network ID over here. So that's it, we provided the network ID. And then the subnet mask, if you notice over here, the subnet mask is in reverse order, because for if you look here, this value should be on the front. I mean, the first digit should be 255 and then 0.0.0.0. so over here I believe these are the wrong over here, because if we look here, if you look over here, this is actually class A. Okay, this is a mistake, this is a typing mistake, and this is a class C. So the class C supposed to be 255.255.0, and this is called actually a wild mask. So the wild mask is you just change the 255 into the 0 and the 0 into the 255. And then if you wanted to check the status, I'm going to define this thing later in this video, so do not panic and don't worry about it if you don't understand what it is. So over here at the end I defined the area, which is the area 0. In this diagram we have only just one. If you look over here, we have only one area, which is going to call area 0, which has a network ID 10.0.0.0. so these are some commands, so you can look into the protocols, database, and the neighbor. We will discuss later in this video. Okay, in this slide I'm going to define what is the router ID and why this is important. Router ID is always in form of the IP address, and if you have a loopback addresses, if you look over here, we have a loopback address and we have a loopback address. If you don't know loopback address what it is, I will make another video on loopback address to give you more overview on the loopback. These are actually the logical email address. If you have logical email address configured on your router, so the bigger one would be your ID. But just in case if you don't have these loopback IP configured on your protocol, then the regular IP, the bigger one, would be your router ID. If there is a no loopback, then your router will look for the physical address, which is 200.1.1.1, which is going to be your ID. So the best practice is to create a loopback or manually set a router ID. You can manually set any router ID, and the router ID can be viewed by using following commands. And if we look over here, I provided these command. Later on this video we are going to discuss all these commands, and then the configuration. If we look here, the configuration is the same. The only thing we added is just the router ID. And then if we wanted to implement that, the router ID, we need to clear the table of Ospf protocol. Over here we will discuss how the area works. So the area 0, as I discussed earlier, is very important in any network. This is called the backbone of any area, because all the other areas, if you look into these pictures, these areas 4, 5, 1, they go through the green area, which is the area 0. So this is very important, and we can also avoid LSA flooding using these areas. I will discuss later what is a LSA flooding. So we have too many technical terms over here, but we will go through all the technical terms slowly. It supports the authentication and the matter cost. The cost is equal to 10 power 8 bandwidth. We will discuss this later when we read how we can change the bandwidth and what are the commands, configuration. But for now I'm going to discuss what is the internal Ospf router. So internal OSPF router means any router inside the area. Like let's suppose this router is inside the area, this router is inside the area, this router is inside the area. All these routers are inside the area. If you look here, these routers are also inside the area. So these all router called internal routers. What is a backbone router? If we discuss the backbone router, any router inside this area 0 is going to call backbone router. So we will now look at the router. Instead of looking into the router, we will look into the interfaces. If you notice over here, let me clean this, and if you notice over here, this interface is inside the 0, this interface inside the 0, this interface, this interface, all these interfaces are inside the area 0. So all these interfaces are called the backbone routers. The next term is ASBR, autonomous system boundary router, which is mean a router which connects the different protocol. Like let's suppose all these areas have a protocol which is called Ospf, but this is a router from where you are going to manage all these areas and router. It is quite possible this area has RIP technology instead of Ospf. So this is where we can call this router as ASBR router. And the next thing is, what is a ABR, area border router? It connects to different area. So when we say it connect to the different areas, that means the router is connecting to different area. Over here has two different interfaces. One interface connects to one area and other interface connects to the other area. So for this, all these routers, they are called ABR router. So if we go over here on the next slide, you will see over here I created a diagram and I assigned all the IP to the routers and switches in this diagram. So in this diagram, if you look closer, I defined three areas: area 0, area 1, area 2. I assigned the network ID from class A, this is a class B, and this is a class A again, and over here the class C and then the class C again.
That's good.
So guys, all we need to do is just go to the router and assign. Okay, so here's we are in the router. Go to enable configuration key, config mode. Here you go, and then we need to type in the command router. Let me show you the command. Here's the command: router ospf and then the process ID, SPF and then the process ID, and then we will provide network and then the network ID. As we are on this router and we are assigning these two interfaces to the area 1, then we are gonna write it down. The first one, 192.168.1.0, and then the wildcard mask. I already explained how to get the wildcard mask. Let me write it down and then I will show you. 255. So this is a class C IP address. This network ID, what is the default gateway? The default gateway is 255.255.255.0. If we convert all 255s into 0 and then 0 into 255, we will get the wildcard mask. But there's a formula. You can use either that formula, like let's suppose just write down all 255s and then you can subtract whatever is the default gateway, 255.0, and the answer we will get is 0.0.0.255. So this is our default, this is our wildcard mask. So we are going to use the wildcard mask for C, class C, and let's go back to the router and here, and then we will define the area, and as you can see, this is the area 1. Okay, so we defined it in the router Ospf area 1. Let me figure it out what happened here, and then let me write it down. Router Ospf, then 1 process ID, and then network 192.168.1.0.0.0.255, and then area 1. Here you go. So there was a mistake on the top. It might be we missed something here, but this is the first interface. Is for 192.168.1.1. Now we will go to the second interface. Actually, we will not go to the interface. We will define all our Ospf protocol for both interfaces. So the next command is going to be almost same, but for this network ID, which is a class A, 10.0.0.0, and then the wildcard mask is going to be very different. It's going to be 0.255, 255, 255, and then area is going to be 1 again. So here you go, and then we will see the status later, but now we will go to the second router. So I'm going to close this router. I will go to the second router, which is this router, and on the CLI I will type in enable config T, and over here router Ospf process ID will remain same as I told you before. You will write network and then you are going to provide the ID, which is a 12.0. This is also a class A, 0.255.255.255, and then area, this is a area 0. When you define area, so be careful, look at the area where the network ID, because if you provide the wrong area, you cannot configure these routers. So here you go, and then the second command would be the network, and then we will provide this interface. This is 10.0.0.2, which is basically network ID is 10.0.0.0, and then the same 0.255, 255 area. Which area is it? This is area 1. Here's the trick. So this is actually inside the area 1, and this is actually inside the area 0, but these both interfaces are coming into the area 1. So this is the trick you are going to do over here. Now we configured this router. We are going to close this router. We will go to this router, go to the CLI. Let me see, let me go over here, config T, and then we will router Ospf, and then process ID, and then we will write down network, and we need to look into this network, which is a 172.116.0.0. this is a class B 0.0.255.255, and then the area is going to be 2. As you can see over here, this is our network ID. We are writing down this interface, so this is area 2. Now on this router we need to work on this interface, which is a class A. So for that interface we are again going to type in the same command. We are going to say the network and then 12.0.0.0, because the network ID is 12.0.0.0, and then we will define a wildcard mask, which is 0.0.255.255, and then the area, which area is going to be 0, correct. Here you go. So we configure this router as well. Now we will go to the fourth router, but first let me clean up the window. The fourth router, let me ask you this question. So we are going to work with this network ID. Sorry, I supposed to write at this place so you can better understand. And we are going to work these two IDs. They are close, they are connecting to each other, so we are going to configure those two on this interface, correct. Let's okay, go to CLI and then over here enable config T, and then router Ospf, and then the process ID we will keep the same for now, and then we will type in the network. So I will say always go whatever is the far network ID first, which is a class C 60.0.0, and then we are gonna say over here 0.0.0.255 because it's class C, and we are going to say area 2, correct, area 2. Here you go. So the both areas will remain same for this. So the second ID would be 172.116.0.0 0.255.255 area 2. Here you go, all the router successfully. So now this is the time to see what we did, is it working or no. So let's go here and let's start pinging from, let me get ping. Now we are going to ping at 10.0.0.1. this interface is this one, which is outside. Now 0.3. here you go. So we achieved our goal. Our goal was connecting two computers, so we successfully connected these two computers. So if you like the video, please comment down below, and if you really want to see more videos on Cisco, let me know and I will finish the course. Thank you so much. Bye bye.